Hello everyone, in this video I'm going to show you how to get 2D graphics from scratch. Next video we'll expand it to 3D graphics, and after that we'll add textures and even lighting. So this video we'll go over how to make a window, how to draw pixels to that window, and then finally we'll draw actual triangles with color. So to get started, open a new terminal and create your project if you haven't done it already. I want my project here, and I'll type cargo new and our project name for now, graphics from scratch. Nice. Let's go over to file, open folder, go to where we made it, graphics from scratch, select folder. Very nice. We're now in our newly created project. So first of all, we need to import our library we'll be using for the window. We'll be using mini Framebuffer with the latest version at the current time being 24. This will allow us to make a window and draw pixels to it. This works on Windows, Mac and Linux, so if you're following along on the different platform, no worries. Then, to keep everything organized, we'll create a second file. And we'll create a window script to wrap our window functionality in. The first function we'll need is our new function to create a new window. We'll pass in a string as the name for the window, the initial width, and the height. We'll also make it resizable later. So some options mini FB requires is mini FB window options, and resize will be set to true and the rest will be set to default. One thing which might be nice to have is that we can see our actual errors. To do that by just saying window, we'll say use window. This is not strictly required. Okay, nice. Now we can actually see our warnings and our errors. Then after that, we'll create our actual window. Mini Framebuffer window new, and we pass in the name, the width, the height, and our options. Then it returns the result. So we'll check if it successfully created a window. If not, we'll print fail to create window. Then after that, we'll return a window. This will only be holding our mini Framebuffer window for now. And we can just toss that in like that. Oh yeah, of course, we need to return self. Okay, nice. So let's also make another function, returning a boolean called should close, taking just self and returning a boolean. What this will do, if not self dot window dot is open, we'll return this. And what we can do now, magically, is we can create our new window with a name and an initial width and height. We can then create a while loop, while window dot should closed, and that should not close, of course. And now, if we run this, you can see that we created our window successfully. Unfortunately, when we try to drag it around, it doesn't actually work. It sort of, well, it's not responding as Windows says to us here. To fix that, let's close it. To fix that, we'll need to create an update function to allow it to poll for our user events. So let's make update. Oops. Self.window.update. This will update the window. This is to be mutable. It will update the window and give the operating system time to say to the window, hey, you need to be resized, you need to be closed, you're being dragged around. Window update. And we call this at the end of every frame And we also need to make this mutable then. So what we have now, we have a window with a height and a title, and as long as it should not close, we will be updating the window. Very neat. So we can move it around, we can make it larger, we can make it smaller, we can even minimize it, and we can close it, and the application closes. Cool. Okay, now for drawing pixels. We'll make it a bit easier, because the pixels in mini Framebuffer are stored as U32s. Red, green, and blue, all the three colors are packed into a single U32, and you need to supply them in the update function to update the window. To make this easier, I'll create a second struct named Framebuffer, containing our pixel data, which will be effect of U32s. This is what MiniFB expects, so we cannot use anything else. And restore our width and our height. Then we'll also implement some methods for our Framebuffer struct. A constructor with width and a height. We'll return our Framebuffer. And our data will be equal to, we'll initialize it with zeros. And we need width times height pixels. And for the width and height, we can just use our arguments. And there. That will be our constructor. Then, to make life a bit easier, I'll also create two getters, one for the width and one for the height. Very nice. And then finally, a very important function called setPixel. This function will need a mutable self. It will require the x coordinate where we want to draw, the y coordinate where we want to draw, and then finally our value of the pixel we wish to set. Self data. So where should it be? Because it's a single dimensional array. So what we're basically doing, we're cramping two dimensions into a single dimension. How we then need to index in this array will be x plus y times self.width. Because our width is sort of our slice, so for every y, we need to move an entire row of x's, basically. And we'll set that to a value. Then our window will need to have a single Framebuffer at all times. And we can initialize this right here. Oh, no, that's not what we want. With new, and we can pass in our width and our height. Okay, neat. So the update function, it's not really update. I would call it more like a display, because we're going to modify it a bit. There are two functions. You have update, but you also have update with buffer. And we want to use this one, because what this allows us to do, if you take a look, it allows us to pass an array of U32s, a width and a height of the area we want to update. So these will be our actual pixel values. So what we can do, self.framebuffer.data as a reference, self.framebuffer.width, self.framebuffer.height. So personally, I would rename this to display instead of update now, because it's also updating, but it's more so displaying our pixels. And we'll need to put expect here because it's returning a result, whether or not we successfully displayed our pixels. If we did not, then unfortunately failed to display pixels. So right now we will be able to draw pixels to the screen. That is, if we expose our Framebuffer, so we can actually call setPixel. Let's also do that. Let's create a getter, public function Framebuffer. And this will return a mutable reference to Framebuffer, which will then turn mutable Framebuffer. So we make it mutable. And what we then can do in our update loop, we can say Framebuffer, excuse me, typing is difficult, window.Framebuffer. Then we can say for x in Framebuffer width, for y in Framebuffer height, and we can set this to an arbitrary color. Set pixel x, y. Let's say 0. So if we were to run this, you can see our screen is black. But how do we exactly use a single U32 to, well, say it needs to be orange, or it needs to be blue, or it needs to be white or teal? So we can do that by having a small function which will bit shift 3 U8 values into a single U32 value. Some of you might already have an idea what I'm talking about. So we can use the following function to actually cramp a red, green and blue channel in U32. If you look closely, we could actually also fit an alpha channel in here, but what would you use that for, as it's a window and it doesn't really have transparency, does it? But it could fit in there easily. So we take 3 U8s, which have a maximum value of 255, and they cannot be negative because they're unsigned. And we convert them to U32s. We just take them as U8s to make sure the user doesn't pass in any number higher than 255, otherwise that information would just be lost. And then we bit shift them, so in the end they will still take up 8 bits, but they will just all be packed in a U32. First if you're red, then you're green, then you're blue, and we don't have any alpha. So if we use this method, we could still say, okay, I want it to be black, so that would be 0, 0, 0. Or we could say I want it completely white, which would be 255, 255, 255. If we now run it again, you can see our window is white. But if we want it purely red, well, you probably get where this is going, we can just set the first value to 255, and then it will be red. Wonderful. So for now, let's just make this sort of darkish gray, setting it to 2020. So now let's take a look at how we can get our x and y and see if it's inside or outside any triangle. First, let's create some triangles. So let's define a few points. The points of a triangle. For this, I will be using a math library. Yeah, I know, it's not completely from scratch. So if you want, you could write your own math library, but for this case, I'll be using Glam. It has just a few math types. For now, we'll only be using the vec2. And it will just come in handy because you can add a vec2 to another vec2 easily and multiply them. But you could also write your own vec2 if you wanted to. So, vec2 from Glam. First, let's say use Glam, and I'll just say use everything. I know it's maybe not the best idea, but it makes life so much easier. So let's make an array. Ooh, excuse me, that's not really an array, is it? Yes, let's make a static array. And let's introduce some points. So for now, the coordinates of these points will be from 0 for the x all the way on the left of our screen to 1 for x all the way on the right. For y, 0 will be on the top and y will be on the bottom. So the first point will be in the top left of our screen. Then our second point of our triangle will be on the top right of our screen. And then our final point will be in the middle of the bottom of our screen. In the middle and then slightly to the bottom. Neat. Now we have 3 points. Let's see. How can we make some sort of statement if inside triangle x, y, and then if it's inside, we can of course say draw this color. If it's outside, we can say draw that color. So if it's inside the triangle, let's give it some nice color. Let's say 100, 150. But now for this function. So how do you know if a point is inside or outside a triangle? To answer this question, we can take a closer look at this 2D triangle and this 2D point on the same plane. How can we know if it's outside or inside the triangle? To solve the question, we can take a closer look at a single line segment, a single side of the triangle. We can compare it with another line segment going from one end of our other line segment to our point. And if we take a look at these variables and at this function, we can calculate the signed area of the parallelogram these two lines can form. If our point compared to our triangle edge is on the right side, our signed area will be positive. If our point is on the left side, it will be negative. So then we can use this knowledge to go back to our triangle and test our point to every edge of the triangle. If the signed area of every test is positive, we can be sure the point is inside the triangle. But if one or more signed areas of one of the triangle edges is negative, then our point is outside the triangle. Now, with this new knowledge equipped, we can write our edge function. So for our edge function, we'll be taking 3 points, A, B, and C, and we'll return the signed area of the parallelogram. Do note, in the animation, A was always in the origin. Of course, in reality, that's not the case. That was just to make the animation a bit easier to show. And we'll return a float. So, as you recall from the animation, we need to do cx minus ax times, because this will form the vector, by minus ay, and then this entire thing, let's put extra brackets around it to make it extra clear, will be minus the following: c dot y minus a dot y times b dot x minus a dot x. So here we have our edge function. Now we can create another function, make life a bit easier. Let's call it inside triangle. Oh yeah, that's also what we got this one. Neat. So again, we'll need our 3 triangle points. In here, I flipped them around to make life a bit easier. You can also flip them around here, but then make sure you enter them here correctly. And here we'll return just a boolean to know if it's inside or outside the triangle. Of course, here we also need our coordinates for P, and this is the point we'll actually test inside this triangle. So, we need to do 3 checks, 1 for every side of the triangle. We'll do area 0, will be our edge function of line segment B, C, P. Then the second area will be the edge function of C, A, B. And then our final one will be A, B, B. Oh, excuse me, this should be B, of course. We need B in everyone. So first we go from B to C, then from C to A, and then from A to B, constantly using point P, of course. Then we can create our boolean overlap, set it to true, and then and equal area 0 is larger than 0.0 because it needs to be on the right side of our line segment. Same goes for area 1 and area 2. As you can see, you could write this entire thing, that you could write this a bit easier because we're just going to return a boolean overlap, of course. But later in this video, we'll add a bit more stuff here, but not much, I promise. So now that we're equipped with our amazing function, we can make our point P. So X is now in the range of 0 until Framebuffer width and Y until Framebuffer height. We need to change that. So P will be vec2, and it will be X as a float divided by Framebuffer.width as a float. So right now we'll remap it in the range of 0 to 1. 0 on the left side, 1 on the right side. Same for Y. That's F32. And now we have a point P. So what we need to do then is grab our point coordinates, points 0, points 1, points 2, and a point B. These will all need to be passed by reference. We don't need to make copies, that's why I make references, but just save some performance. And if we try this out now, we should see, wow, our triangle. Ooh, the color's not that good, unfortunate. But you can see we have our triangle and we have our background. But what if we resize the window? It sort of works, but as you can see, it's quite pixelated. Maybe we also want to resize our actual frame buffer, because we're not doing that right now. So in order to resize our frame buffer, what we can do, we can go back to Windows. Unfortunately, the MiniFB library doesn't really have a callback for resizing. But I found a very elegant solution for this. We can get the width and the height every frame we display by saying self.window.getSize. And what we can do then we can compare it to our current frame buffer size. So if our width doesn't equal our current frame buffer width, or the current height of the window doesn't equal the current frame buffer height, then we want to assign a new frame buffer. We can just assign a new frame buffer, because it's not being used by the user, with a new width and height. And that solves all our problems. So if we were to use this code now, you could clearly see, if I make it full screen, the resolution scales up as well. One funny thing, to make sure it works, you can make the window very small, and then you can make it very large without releasing your mouse. You can see it's very blocky, and when I release the mouse, it will actually trigger the on resize, and whoop, good to go. However, be aware, the winding order of the triangle matters. If it's clockwise, then the point will have signed areas of a positive number. If the winding order is counterclockwise, all signed areas will be negative if the point is inside the triangle. So, now that we know that the winding order actually matters, let's see if we can prove it. So let's reverse these two. So what we have right now, we have top left, then we have bottom middle, and then we have top right. If we were to execute the exact same code, you will see that unfortunately our triangle disappeared. But if we fix our inside triangle function and make sure, oh, that's not good, and make sure that all signed areas are smaller than 0, then you will see our triangle reappears. So this means our triangles do need to have the same winding order if you want to draw multiple at the same time. For now, we'll go with the clockwise winding order. And there you go. Okay, so what if you want exactly the same as the thumbnail did? The thumbnail had a few more things. It had 3 triangles, but to also speed things up a little bit, because the CPU isn't that fast, you can see we had 3 triangles, so 9 points. But we also did something else. I did a small optimization, which was not writing unnecessary pixels. So in here, we're looping over all pixels on the screen. But as you could see, not all of them are actually inside the triangle. We can do a pre-check basically to see in what range our for loop need to go to draw the pixel or not. To do this, I'll create another function called draw triangle, and I'll give this again our 3 points of the triangle. And why not, let's also give it a color. Nice. This of course also needs our frame buffer to write to. And then we can move our for loops in there. Nice. So we'll write using our color if we are inside the triangle. Now we can call this function as many times as we want with our corresponding points. And any color. let's for now say, previous color was quite ugly, wasn't it? Let's make it a bit brighter. 200, 150, 100. Nice. Oh, did the C, I'm sorry. We also need a frame buffer, of course. Okay, now that we have a new function, we can add our logic to optimize things a bit. So what we'll do, we'll basically create a small bounding box around the triangle, see the minimum and the maximum coordinates on the screen, and we'll only loop or for loops over those areas. So what we can do, first, to make things a bit easier, I'll just put these two in variables so I don't keep typing the same thing. Nice, and I can replace these with these. Clean things up a bit, otherwise it gets so messy. Ooh, that's not good, is it? Nice. So let's get the minimum. What we need to do to get the minimum, our math library has something very fancy built in. We can take our first point and say, take the minimum of this point and another point. That other point will be the minimum of B, and our final point, C. It's a reference, and this library doesn't take references, so we need to dereference it, unfortunately. And that will be our minimum. Then for our maximum, we'll take the maximum between A and the maximum between B and C. It might be a bit confusing at first, but if you look a bit closer, I'm sure you'll get it. Then one final thing, the minimum cannot be smaller than 0, otherwise we're drawing out of our frame buffer and our application will crash. So we'll make sure that it's at least within factor 0. Same for our maximum, it cannot be larger than 1. So take the minimum between our final result and factor 1. This will just be 1. So now we're almost there, except that we have one problem. Our minimum and our maximum are still in the range of 0 and 1. And for our iterators, they need to be in the range of 0 and the width, and 0 and our height of our frame buffer, which will be, for now, 512 and 512. So to achieve this, we'll multiply them with a factor 2, with width as f32 and height as f32. Same for our maximum. So this will rearrange them from 0 to 1 to 0 to width and 0 to height for our minimum and our maximum. What we can then do, instead of 0 to width and 0 to height, we can use our minimum.x as u size until maximum.x as u size. Same for our y, minimum.y as u size and maximum.y as u size. So if we run this, you can see that nothing really changed. It still works. That's because right now we're just not updating these pixels. We're not checking these pixels and these pixels. We're only really checking inside this square, because around that we can be sure the point is not inside the triangle. To really visualize that, we can make an else statement again, and we could also set this to color. Excuse me. Oh, it doesn't like that. Let's say divided by 2. So now it's a bit darker. So if we run this, it becomes really clearly that it only really checks this square. But what if we want to draw a background color? And maybe we want to clear it every frame. If we resize it, it will clear it. Because we create a new frame buffer, but we probably want to clear it as well. So that will be the final thing we do. So we'll remove this. Because black is a bit boring, maybe we want orange or yellow as a background color. Inside our window, we'll create a final function on our frame buffer, and we'll call it clear, and we'll give it one argument. That will be the color to clear it with. Then we'll just loop over our data for y in self data length 0, 2, and we'll say self data y equals color. And now before we draw any triangles, we can say framebuffer.clear with our color. For now I would like to do a darkish gray tint, 2020, And if we run it again, we can see before we draw any triangles, we get this nice darkish gray color, and we get a triangle in the middle. So to have the same as the thumbnail, we can loop over all our points for y in 0 to points length, and then we can say, oh yeah, of course there are 3 points per triangle, so we need to divide this by 3. Then we can draw our triangle every time we have gathered 3 points. Let's make this a bit more readable. Nice, like that. And then instead of point 0, 1, and 2, we use point I times 3. Point I times 3 plus 1, because there are 3 points in every triangle. I times 3 plus 2. And then to even give them different colors, I'll set this to 100, I'll set this to 50, and then for the red value, I'll say y times 100 plus 100. This will mean the first triangle will have a red value of 100, the second 200, and the third 300. We need to cast this to 8. And there you go. That will be the first tutorial of this tutorial series. In the next video, we'll be making these triangles into 3D. So we'll be rotating them, we'll be scaling them to be close and far away from the camera. We'll move the camera around. And then in the final tutorial, we'll add textures and some basic lighting to them. And we'll actually load some 3D models. So I hope to see you next time. Bye.